Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows compiler. Today we will continue with our creation of a dashboard application using the PowerBasic Windows compiler and RmChart. In our last video, we used the chart designer within RmChart to design a dashboard. We saved the format of that dashboard in this RMC file. If we double click on this file, we are back inside the designer. We have designed a chart with two pie charts, one reporting on incidents and one reporting on requests. Also for our users, we've designed an additional chart below both of the pie charts. This is a line chart reporting on incidents per hour. The chart designer is very useful in that it can be used to prototype a chart or charts in your dashboard. You can then show them to the users and agree on what the dashboard is going to be looking like. Say for example our users came back with some feedback to say that the legend below the pie chart was a little close to the legend of the other pie chart. We can quite easily remedy that by narrowing the size of each of the pie charts. For example, from 395 pixels down to 390. And having done that, our legend is now well separated from the legend of the other pie chart. So we can save our profile, and we're going to get the source from the designer, which we can paste into our application. We can then go back to our application, highlight everything, and paste in the updated source. We can then take out the path to RmChart, which exists within our folder. If we then run our application now, the chart comes up as we have designed it. What we're going to look at today is the code which underlines this chart, and how you can amend this code to add extra facilities, namely where the information actually comes from. At the moment, we've hard-coded all these values inside the application. We're going to change that so that the information comes from outside the application. And other things on the chart, for example the dates, can be generated dynamically. But before we do that, there's one more thing I'd like to show you on the application as it stands now. One feature which is already built into this code is the ability to drill down on a slice of the pie or any part of the chart. If we hold down the control button on the keyboard and then left click on the mouse, a pop-up appears. This is driven from inside the event handler of the dialog. It provides information on what you have just clicked on. For example, it tells you it's data index number 2. It's the second slice of this pie. It also tells you the values. Since this event is actually trapped, this allows you within your own code to actually do something else. For example, a drill down. This slice of the pie is showing 12 incidents. You could, on this event, trigger it to display an additional piece of information, say for example a grid, showing you the actual 12 incident details themselves. If we look at the line chart and do the same thing, it gives us the information that it can pull back from that chart that you have just clicked on. Data index 7 and the position on screen and the actual value. So this is giving you a hook in the code into which you can add your own functionality. We'll be covering that in a later video. But for now, let's have a look at the code. In our application, there are 3 include files at the beginning: the RmChart include file, the Windows API, and the common dialog. If we look at the PB main function, we'll see that the form that has been launched is one called show dialog RMC. The detail of this function is to create the dialog, position the buttons on it, and then call a single function called doTheChart. This function provides all the functionality to display our multi-charts on our dialog. Let's have a look at that function. There are a number of local variables set up at the top of this function. We'll come back to those later. If we look further down, you'll see there's a section headed Create the Chart. This is the part which actually designates how much space the chart is actually going to take up on the dialog, 800 wide and 700 in height. It sets the font in use and it sets details of each of the regions. Each region in this case is a separate chart. 2 regions for the pie charts and 1 region for the line chart below them. Now in here you can see there's a section for the footer, and this is where the created date is going. So what we're going to do, we're going to replace this piece of hard coding and we're going to put into it the actual date, pulled back from Power Basic itself. So if we go back to our PB main, we're going to set up a global for power time. We're going to use the inbuilt power time class. We'll set this myTime as an iPowerTime variable. And we're setting this to be class powerTime, and we're setting the value of the myTime variable to be now. That's the current date and time. So having set that, we can now go back to our doTheChart function. And where we have created on the 23rd of October, we're going to amend that for the current date. We can set that quite easily by adding on to the string the variable myTime dot date string long. So if we run our application now, you will see that the first chart, the pie chart, is showing 30th of October. So we can do exactly the same for the second chart. If we look down, you'll see there's details of each of the legends and regions. And we'll find another where the footer has been set. And we can paste that in too. So now both of the dates are showing the current date. And every time the application runs, this will be recalculated. So below that in the code, you'll see there's an add caption to region 1. This is where the heading is actually set, the incidents per division. Although we have this hard-coded into our application, this could be coming from somewhere else. This could be coming from a text file, or it could be coming from a database. And further down still, you'll find there are the legend headings. Now these have been hard-coded into the application, and it's a delimited string delimited by the asterisk character. We're going to amend this so that this data is not actually coming from inside the application, but coming from an external file. So in order to do this, we're going to add 2 libraries. The PB file handling routines library, which we've used many times before, and a new library explicitly for RMChart. So we will add these at the beginning of our application. And just for ease, I will copy both of these libraries into the same folder as our application. So we're going to take these values from a flat text file. This flat text file will hold 2 pieces of information: the name of the division, for example marketing, and the value we want to display on the pie chart for that division. And we're going to bring this up in a file called incidents.csv. This will contain a list of divisions and the values in those divisions. And the idea being, since we're taking this from a file, we can extend the number of divisions that our pie chart is going to report on. I've added 2 extra divisions, IT and Oversight. So our pie chart will then be driven entirely by what's within this file. So how can we do that in the code? Well, for the moment we will comment out this line of code where we're setting the value of the legend. And we're going to call a function in our new library called getDivisionNames. This takes a single parameter, which is the path and the name of the file which contains that information. The file we looked at a moment ago, incidents.csv. Now that we've got the legend handled, we want to handle the actual data itself. If we look slightly further down the code, there is an add series 1 to region 1. This is where the data is actually added to the pie chart itself. And we'll see that there is an array prepped as 0 to 3 elements, in other words 4 elements in the array, and the data is hard-coded into the following line of code. And then we call a function within the rmchart DLL which displays that on the screen. So we're going to replace that with our own piece of code. So we will comment out these 2 lines. And we're going to call another new function in our library called getDivisionValues. And all this function is actually doing is it's reading the incidents.csv file, and it's populating each element of this double array with the value that it finds. So the 0 element will be 11, the number 1 element will be 13, and so on. Now there is one additional change we have to make. In this function here, which is displaying the pie chart on screen, it takes a number of parameters. One of these parameters is the array which contains the information. We're passing the 0 element, and that gives that function the information to know where to get its data from. It's followed by a number 4. Now this number 4 is not an arbitrary number. This is the number of elements within the array. To make this more readable, we're going to extend this slightly. We're going to change it from 4 to the calculated value of how many elements in the array. If we use ubound adata, it will dynamically calculate the number of values in that array. So the array will be populated by our new function, and the pie chart should display the values correctly. So let's try running that code now. We'll see that the pie chart now has a number of different slices. It has the IT and the oversight slices added. So our dashboard is now displaying information dynamically. As you can see, we're slightly truncating the name of human resources. So as such, we may have to adjust the positioning of our pie chart on the screen to allow all the data to be shown. We could probably do with making the whole thing slightly wider. But we'll push on with the second pie chart. We're going to do for it what we did for the incidents. I've created a file called request.csv, and as before, this will contain much the same kind of information, a list of divisions and a list of values. We can then use the same 2 functions we used before to populate the information on its pie chart. If we look further down in the code, there's a section for Add Region 2, and there will be a section for adding the legend to Region 2. So we can replace this existing line of code with our call to get division names, specifying the name that contains the information. And if we move slightly further down, where the data is actually populated, we can comment out the original lines of code and put in our call to get division values, specifying request.csv. And as we did before, we will replace this 4 with a ubound command. So if we run our application now, you will see we have more slices of the pie for requests per division. However, you'll see there's a problem with the colours in the legend. What is actually causing this is that we specified a colour array to hold the custom colours we wanted for this particular pie chart. And we set it up for having 4 slices of the pie and 4 only. Therefore, since we've added additional slices, these are defaulting to the colour black. Now we can get around this. We merely have to populate more colours in this array. So for the moment, we'll comment out these lines of code. So the question is, where will we get these colours from? We want them to be dynamic. We won't want the user to have to key in extra colours when additional divisions are added or taken away. If we have a look in our folder, we'll see there's an rmchart include file. If we open this one up, this is the one that's provided by rmchart. The very beginning of this file are all the colour constants. These are the names and the values of each of the available colours, and there are a great many of them. So if we save these colours to a flat text file, we'll get this. And we can use this with another function in our new library. So we will call a new function getRandomColors. It takes a number of parameters. First of all, the array we wish to populate, the number of entries there should be in that array based on the entries in the data, and the colour to start at. As you'll notice in the function that we call in RMChart to display the pie chart, we have the entry for the data. We have the entry for the number of elements within that data array. We've also got the colour array and the number of elements in that. So since it's hard-coded for 4, we need to replace that with another ubound command. This makes it entirely dynamic. So if we try running our code now, we'll see we get a number of different colours. They may not be exactly the colours you're actually wanting, so we can create a custom palette. At the moment, it's pulling the colours off in the order they're in this list. So if we create a cut down version of that list, containing some colours that we actually want, it can be as many in here as you wish. We can refer to that in the code by using another function, getFixedColors, and it takes a parameter which is the list of colours and the order you want them to appear in. If we run the code now, this gives something a little more aesthetically pleasing. So now we've shown some customization of the two pie charts, taking their data and their legend information from a flat text file. You can of course replace these functions with functions of your own, which take the data from anywhere else, perhaps from elsewhere in your application or from an entirely different system or a SQL database. We're going to do the same for the grid. However, we'll do that in a separate video. There are two further things I'd like to talk about in this video. One is the help file that ships with RMChart. If we look at the installation folder that we covered in the last video, you'll see that in that installations folder there is an RMChart help file. You will find this help file very useful. It goes into quite a lot of detail of how RMChart actually works. It covers the designer and the basic concepts of how the designer works. It covers using the DLL, which we're currently using, and a number of different functions, and details of their parameters. When you want to expand on the functionality provided by the designer and add these functions elsewhere in your code, this is the first place to go and look to see how these functions actually work. The other thing I'd like to talk about is the installation of your dashboard on someone else's computer. When we ran the installation, the rmchart.dll was installed on your machine, and the folder into which it was installed was the Windows syswow 64 folder. If we look for RMChart, you'll find there are two files beginning with RMChart, the DLL and the ActiveX control. As we're using the DLL, this is the one we're interested in. We can quite happily copy this DLL and we can paste it into the folder containing our executable. And there's the DLL in place. Now with this DLL in the same folder, when it comes time to release this application for other users to actually make use of, the only files we'll need to actually roll out are the executable, the DLL, and our requests and incidents and colors if we're using them. This way, your dashboard application can actually sit on a network drive, to which users have read-only access. Users can then run the executable, display the charts on their computer, and should you need to update the chart application, you merely have to replace the executable. The DLL or even RMChart does not need to be installed on everybody's computer. So in summary, we've showed how the information can actually be populated dynamically. We've shown that there are pre-existing events in the code that allow you to click or right-click or control-click on individual slices of pies or parts of the charts. This allows you the facility to trigger drill down into other parts of the application. Hopefully you'll find this code useful in your applications, but That's it for today. Thank you for watching.